Welcome back. Problem 6.22. So draw the shear and moment diagram for the overhang beam. So you can see this is a overhang beam clear from point A to B. There is a uniformly increasing load, and from B till the end this is a uniformly distributed load of 4 kilonewton per meter. The total length of the beam is 6 meter. So what we have to find is we have to find shear and moment diagram. So let's start with the solution. The first step is in solving this problem is to find the reaction force at point A and point B. So this is point A and this is point B. So if you remove reaction force, so definitely there will be a reaction support. So definitely there will be a reaction force RB, and let this is reaction force at point A is RA. I have taken RB upward and RA downward because you can see due to this load, this reaction force will be upward and it will tend to move this beam upward. So RA should be downward. So we'll find these reaction forces by using equilibrium condition. So you can see that from point A to B there is a uniformly increasing load. So if you want to convert it into concentrated load, so it will be equal to, at this point this is 4 kilonewton per meter. So this this load is a triangle, so area under this load will be give you the force. So this will be equal to 1 over 2 into its height, which is 4 kilonewton at this point, and its length 3 meter, and it will act at a distance of 3 by x by 3, means length is 3 by 3, which is 1. Clear? Now similarly this 4 kilonewton uniformly distributed load acts on this portion. So this will, if you convert it into point load, so it will be 4 into this length 3, and it will be acting at the mid. So mid is 1.5 meter. So we will use first equilibrium condition, that sum of all moment about point B is equal to 0, and this will be used to calculate RA. So from this you can see the moment about point B is due to this RA, and perpendicular distance is this 3. So, and it is counterclockwise, so it will be positive. So RA into 3 plus the second counterclockwise movement is due to this load, and the perpendicular distance is 1 meter, and it is also producing counterclockwise. So plus 4 into 3 is 12, divided by 2 is 6, 6 into perpendicular distance is, this is 3 by 3 is 1. The other movement that is produced due to this load, which is 12 into perpendicular distance, is 1.5. So this is counterclockwise, so it will be negative. So minus 12 into perpendicular distance is 1.5. Their sum must be equal to 0. So 3RA plus 6 minus 18 is equal to 0. So from here you will get RA will be equal to 4 kilonewton. Now you have this RA, you can also find RB. Sum of all forces along y direction must be equal to 0, and taking the upward force as positive. So one force RA is downward, the other RB is upward. This force is downward and this force is downward. Their sum must be equal to 0. So minus RA plus RB minus 1 over 2, this term 1 over 2, 4 into 3, which is 6, and minus this 12. Their sum must be equal to 0. So from this is RB. So when you put the value of RA, so you will get RB is equal to 22 kilonewton. Now we will move toward our basic part, that is to find shear force and bending moment diagram. So you can see that from point A to B, this load is uniformly increasing load, and then load is discontinuous, and then at the remaining portion this load is distributed load. So we will find the shear force and movement equation for region AB, and then for this region BC. For region AB, we will get x is greater or equal to 0 and less or equal to 3. And for this region, we will take x is greater than 3 and less or equal to 6 meter. And we will find the shear force and bending moment equation. So first we will find the for region x is greater or equal to 0 and less or equal to 3. So it means that you will cut the beam somewhere between A and B. So when you cut the beam, so you will get the free body diagram will be like that. You can see at this point, this is point A, you have RA, which is 4 kilonewton. Then you have a uniformly increasing load, and this distance is taken as x. So when you cut the beam, there will be a shear force and there will be external movement, and this load is now 4 multiplied by x by 3, because at this point you have 4 kilonewton. So when you cut at a distance of x, so this load will be 4 into the remaining, this is x, so this will be x over 3. Clear? So we will now solve this. Sum of all forces along y direction must be equal to 0, taking the upward force is positive. So you can see one force that is 4 kilonewton, that is downward, so minus 4. And the second force, when you convert this uniformly increasing load, so it will be 1 over 2 into 4x by 3 into x. Clear? So I will write it, and this is negative because it will be downward. So 1 over 2 into 4 over 3x, and perpendicular distance is x. I will also write it over here. When you convert it into point load, so 1 over 2, 4x over 3, and this x distance. And it will be acting at a distance of x by 3 from this denser side. Okay, their sum must be equal to 0. There is a shear force as well, minus v. Their sum must be equal to 0. So when you solve it, you will get v is equal to minus 2 over 3x square minus 4. And the unit will be in kilonewton. Let this is your equation number 1. Now we'll find the moment, so sum of all moment is equal to 0 about this point. Let this point is 1, so I will write 1 so that you should not confuse. Now about point 1, you have external moment m, and the second moment is 4 into perpendicular distance is x, and third is this load into perpendicular distance is x by 3. So external moment m plus 1 over 2 into 4 over 3x into x into perpendicular distance x by 3 plus 4 into perpendicular distance x, their sum must be equal to 0. I will show you this m is this one. So this load is this one, which is given over here, and perpendicular distance is x by 3. And this load 4 into perpendicular distance is this. All moments are counterclockwise, therefore they are all positive. Clear? So from here you will get the moment equation. If you simplify it, will be 2 over 9x cube minus 4x. And unit will be equal to Newton into meter. So this is equation number 2. So equation 1 and 2 are valid for region x is greater or equal to 0 and less or 3. Now we will go to region x is greater than 3 meter and less or equal to 6 meter. So if you look at I have already this diagram. So you can see total length is from this point till this point. This is total is 6 meter. Clear? So when you cut it over here, so let this is x, and x you can see that is greater than 3r. So this is x and this will be equal to x minus 6. So we will take this portion and we will draw the free body diagram. So this is the remaining portion where you have a uniformly distributed load. This load is 4 kilonewton per meter, and when you cut it over here, so definitely there will be a shear force V and there will be external moment M, and this distance is 6 minus x. So one correction that you have to take, this distance is 6 minus x. Why? Because total is 6 and this is x, so remaining will be 6 minus x. So we will apply the equilibrium condition that sum of all forces along y direction is equal to 0 and upward force is positive. So we have two forces, one is this shear, another one is this one, which is 4 into 6 minus x. Their sum must be equal to 0. So V, which is upward, so V minus 4 into 6 minus x, their sum must be equal to 0. So from here you will get V is equal to 24 minus 4x, and the unit will be into kilonewton. This equation is equation number 3. We will find the moment sum of all moment. Let this point is point 2, about point 2 is equal to 0, and taking the counterclockwise moment is positive. So the first external moment is m, that is clockwise, so it will be negative. Second moment will be 4 into this distance, and it will be acting at a distance of 6 minus x divided by 2. So minus m minus 4 into 6 minus x into 6 minus x divided by 2. Their sum must be equal to 0. So from here you will get moment is equal to minus 2 into 6 minus x whole square into kilonewton. This is your equation number 4. Now equation number 3 and 4 are valid for region x is greater than 3 meter and less or equal to 6 meter. So we have shear force and bending moment equation for region 1 as well as region 2. Now we will plot them in order to find the shear force and bending moment diagram. So what we will do is that I will write equation 1, 2, 3. You should note them. This is equation 1, this is 2, this is 3, and this is 4. I will write it over here, and so that we can easily draw the shear force and bending moment diagram. So equation 1, V is equal to minus 2 over 3x square minus 4 kilonewton. This was your equation number 1. Moment is equal to minus 2 over 9x cube minus 4x kilonewton into meter. This is equation number 2. Similarly, V is equal to 24 minus 4x and the unit will be in kilonewton. This is equation number 3 and moment is equal to minus 2 into 6 minus x whole square kilonewton into meter. That was equation number 4. Now you have to draw the shear force over here, which will be in kilonewton, and how we will draw it. So you have equation number 1 that is valid for x is greater or equal to 0 and less than 3 meter. So at x is equal to 0, when you put x is equal to 0 in equation 1, you will get shear force. You will get shear force V is equal to minus 4. You can put x is equal to 0. So V is minus 4. Now at x is equal to 3 meter. At x is equal to 3 meter. So shear force at x is equal to 3 meter but slightly on the left side. So when you put x is equal to 3 meter in equation 1, this is equation number 1. So you will get V is equal to minus 10 kilo Newton. Okay, so we will plot it. Let each point is of 5. So 5, 10, 15. Similarly, minus 5, minus 10, minus 15. So at x is equal to 0, it was minus 4. So minus 4 is, let this is minus 4. At x is equal to 3. So this is 3 meter. You can see I have projected it. So this is 3. So at x is equal to 3, it's minus 10. So minus 10 is this one. Now shear force is second degree equation and negative. So it will be, this will be a second degree curve and clockwise. Okay. Now at point B we have RB is 42. So this is minus 10, 22. Minus 10 plus 22 is 12. So 12 will be this point. So shear force will suddenly change from minus 10 to 12 kilonewton. Now for this region we will use the equation of shear force, equation number 3. So you can easily put at x is equal to 6 meter in equation number 3. So you will get V is equal to 0. So means that shear force at this point is 0, and since the load is a constant load, so the shear force will be first degree line and it is the load is downwards, so slope will be decreasing and it will be a straight line. So this is your shear force diagram. This is 0. This distance is 3 meter and this is also 3 meter. Now by using, you can also use shear force diagram in order to find this bending moment, but you have the equations as well. You can just put, so at x is equal to 0. So when you put it in equation 2, x is equal to 0 in equation 2, you will get moment is equal to 0 because you can see this is x, so moment will be 0. Similarly, at x is equal to 3 meter, so moment when you put it in equation 2, it will be minus 18 kilonewton into meter. So you can plot it. X is equal to 0, moment in kilonewton 2 meters. So at x is equal to 0, moment is equal to 0. Let each one is of 5. So 5 kilonewton into meter, 10 minus 15. Downward is negative, upward is positive. And 18 will be somewhat here. So at x is equal to 0, movement is equal to 0, and at x is equal to 3, the movement is minus 18, which will be this one. Now you can see that the shear force is a second degree curve, so the movement will be 1 degree higher, and it will be also a curve in this form. It will be not a straight line. It will be 3 degree curve. Okay. Now at x is equal to 6 meter. So when you put in equation number 4, so 6 minus 6 is 0, 0 into 2, 0, so moment will be equal to 0. So at x is equal to, it will be 0. And again you can see that shear force is this one. So area under the shear force, you can see it will be, the slope is decreasing and it is first degree line, so the bending moment will be second degree, and it will be again clockwise. When you draw this, it will be a clockwise. Okay, this is minus 18. So this is how we can find the shear force and bending moment diagram for the given loading. I hope you have enjoyed this video, and again, if you are new to my channel, then subscribe it and keep watching. Thank you.